Okay, this is going to be a solve of the round of 32. This case is called Give Me a Hand, which is all about cards. So there's some quite instructive things in here. Normally I would use a lambda called card details, and that will just give me all of the cards, you know, their normal values 1 through 13, which is actually how the values are assigned in this case. And then it's quite easy for me to do an XLOOKUP to get values by doing kind of, you know, XLOOKUP all of these in here and find the value. Now the unique thing about this case is that the hearts and diamonds are actually a slightly different symbol to the hearts and diamonds I have in this list here. And in the last question we get completely different symbols for cards. So if we're to keep the case in this format, we need to do a lot of it from fundamental principles rather than from lambdas. One thing you can do in this situation is to replace all of the old hearts with your preferred symbol, and then I can do my lookups, but I think for instructive purposes I'll leave the case as it is and just show how to pull things out. So let's actually start with the bonuses. Using level 2 rules, what is a total sum of a standard full 52 card deck, we can see that the cards line up with their number and every other card is worth their standard value. So I know it's just going to be the sum of kind of all of this in this lambda, 364, 364. If you were to do it without this mapping, generally you would create that as part of the case, or you would create a list kind of ace 2, 3, 4, and then just assign your numbers here, times this by 4. Which card is not included in the 20 hands featured across levels 1 to 3? So we can say equals 2 col of vstack. Let's do questions 1 to 3. And then we will want to do a unique of that. Unique, and we get a list of cards, so let's sort it, and then we can sort of do this by inspection. We can see there's only 3 6s and we are missing 6 of clubs, so let's do 6, find a club symbol, which is here, so let's copy that and attach that to the end. Then we have some kind of combinatorics questions. How many unique hands of 4 cards exist in a 52 card deck? So we essentially, this is just a math problem of given 52 things and you pick 4 of them, how many combinations are there? So to do combinations, you would have 52 choices for the first card, 51 for the next card, 50 for the next card, and 49 for the next card. So if you multiply them all together, you'll get your answer if I put an equal sign in front of it. Anyway, another way to do this is there is actually a formula in Excel called permute. This is a native Excel formula. So 52 things and I'm choosing 4 will give me the same answer, and it's the same calculation underneath. You also have combin, which is combinations, so that will be a lower number, so this is where order does not matter. So those are just 2 good formulas to know. Okay, and then the next bonus is how many of those combinations will allow a player to discard a card. So I'll do this now, but later on the rules say that you can discard a card if either the first and last card have a matching number or a matching suit. So we basically want to go through the options again. So we have 52 choices for the first card, and we might as well just do the 4th card now. So let's think about it. If we want the number to match, there are 4 of a given number, like 4 6s in a deck, 4 7s in a deck. So if we want to match this first one, there's only 3 remaining cards, options, where that is true. And then we're going to have 50 choices for another card and 49 choices for another card. And the order that I do this multiplication in doesn't matter. I could put the 3 on the end. It will be the same. And we also want to add on where the suit is the same. So there's 13 of each suit in a deck. So we have 52 choices for the first card. If we want one of our choices of card to match, then there's 12 other cards left of the same suit. And we have 50 choices for the next card and 49 choices for the remaining card. So that is how you kind of do that combinatorics type stuff. Okay, this is related to level 7, so we'll wait until we get there. And the first question is basically counting how many hearts are in there. So I'm going to say equals concatenate this, and then I'm going to say count occurrences, which is one of my lambdas, count occurrences of, I want to XLOOKUP heart in here, give me the symbol. So I count occurrences of the hearts in that string. There's a few other ways to do this as well, but that one will be fine. Now we need the values. So this is going to be fairly instructive. So as I said at the start, I could just look up to this if I changed all the cards, but I'm not going to do that. So let's think about how to separate card values from the suit. So to get the suit, that's quite easy. It's just going to be the right of this. And then separating the numbers is a little bit harder, because if you do left, you're going to get all the right values out except for the 10, because the 10 has 2 digits. Now, because of this problem, you can find and replace all 10s with a 1. If you wanted to extract the 10, I'm not going to solve the question like this, but it's just for an explanation. We now have regex, so you can actually say regex extract from these, and the pattern I want is \w plus, so it'll give me any word. I think of W as word, it's just essentially word characters. And what that will do is it will split out anything that's not a symbol. So you then get all of the letters and numbers out, including the 10. For less things to type, I am just going to use left. I'm going to make a quick mapping table. So ace equals sequence of 9 starting at 2. And then I'm going to do jack, queen, king. And I'm going to just label this sequence of 13. Now this sequence is actually numbers at the minute, and when I rip things out of text with left, it becomes text. So let's turn those into text. So I'll say and a blank, and then we can do the XLOOKUP. So we're going to say XLOOKUP, all of that stuff in here, give here, and we want to sum it all together. Our 10 needs to be a 1. So let's copy these as values, change that to a 1, 1 and blank. And now we get the answer out. Now we have a very hard question. So we want to find all sets and runs and add up their value. So we know how to do the values, but getting the sets and runs is actually very difficult. So I have a lambda now that does this called card runs or card sets. So I can take a list of cards, give me how many I need. So if it could be 3, and then I can say if ace is high or low. In this case, ace is high. So that will actually give me any cards out that match that. If I was to say 2s, it will give me everything that matches a 2, and it will give me in order. So king of spades, ace of spades, queen, king, 9, 10, 10, jack. So really, it will give me anything that's 2 or above in this case. So if there was ever overlap, like multiple sets of 2, within these 3 cards you get 2 sets of 2, I can choose what to do with it after that. It also works on things like this, where we have non-standard suits. So let's just do 3, and you'll see it pulls them out just fine. So let's do the question, and it's not really fair for me to just use a lambda and go, oh, that's how you solve this question. So I'll just briefly explain what's underneath the lambda. My other option on this lambda is sets instead of runs, so that will pull out like 3 of the same card, or 4 if there were 4. So what I want to do is I want to say XLOOKUP left, just like we did before, of that in here, give me here. And I want to sum it, and then I want the same thing, but for the sets. So even with a lambda, I mean, there's still a fair few things to type out. So let's get sets instead, and that should give me all of the answers. Now I have some errors here, because sometimes I'm not finding a set or run, so I just need to amend the XLOOKUP to have a 0 if not found. There we go. The reason for that is if I was to do kind of sets or runs on here, there's none, so my lambda would spill not found. And obviously I can't find not found in this XLOOKUP list. Let's quickly explain how the lambda works. So I'm basically pulling out unique of the right of this by column. What I then do is I attach on, I say this list, and within the lambda I create this list to have either ace high or low, depending on my options, and that. So we get all of the cards kind of in order. Then I 2-col it by column, and then I say, and this is all within the lambda, scan blank, this is my array, lambda a v, and then I say if the right of v, so i.e. the suit, equals right of a and dash and v, otherwise give me v. And what that does is it spills kind of all of the runs there. And then what I'm doing in lambda is saying text after that dash, and the instance number is minus, so minus from the end, 3 or 4 or 5. This is how many cards in the run I need. And what you see is I then get all of my options out for 3 runs or 4 runs or whatever. I then just filter out any errors there, and it gives me all my possible runs. And then I do text join these after a sorting with a dash. And then what I do is I search this list in here, and if it appears, give me it back, otherwise give me 0. So then that gives me out all of my runs, and then I just retext split it on the dash and take the unique of them. So it gives me all the unique cards that make up any number of runs there. For the sets, I basically do most of left of this. This is the other option in the argument. This is much more simple. And then if anything's above my threshold 3, I filter this list down to say, okay, kings are above 3, give me all of the cards that have a king in front. So that's how the lambda's working. Okay, now on to an easier question. So this is kind of the second section of this case. We essentially have the rules that if the first and fourth card have the same suit, our score will be the value of the middle cards. If they have the same value, our score will be the score of all cards. So let's just grab up here where we had our formula to pull out the value of all cards. So let's pull out our formula to have the left of those. And then instead of the sum, we want to just have all the cards spelled out by value. So I can say if this equals this, give me the sum of all of this. Otherwise, if the right of this equals the right of this, so if the suits are the same, then give me the sum of the middle two. Otherwise, give me nothing. And I had a bracket wrong there. So our answer is 6. So let's just put that in bold and pull that down. So this will be our answers for that one. Question 5 is basically the same thing. The only difference is it's asking for the maximum between the value of cards that are discarded or the value of cards that are left in your hand. So the easiest way to do that is to just get the value of all the cards in the hand and minus off what was discarded. And then you have the value of cards left in your hand, the value of cards discarded, so we just need the max of those two numbers, and that will be our answer there. So let's drag that down. And then question 6 and 7, these are exactly the same question, it's just in question 7 we have different suits. But essentially we're playing that game of matching up the first and last card either on suit or value, and then we have rules about what we replace the discarded cards with. So we have a list of cards and we replace them with, if we match something in the first 4, we pull something out of the next ones. If we don't have a match, we discard a card to the side and pull it back in later. Instead of going through all the instructions now, because there's a lot of them, I'll just build it and explain as I go. I don't necessarily have a very good solution for this, but I have a solution that works, so I'll do that. We'll see how we go. I'm going to build it for level 7, because if you build it for level 6, it solves level 7 anyway, but you just have to extend your columns out. So why not build it for level 7 first and then put level 6 questions in? It should still work. I haven't built it like that before, but let's do it now. So let's go example 7. This is just pulling my data table. So what do I want to do? I want to pull out what cards are in play. So let's call that in play, and it's going to be the first 4. And then the cards that are in a pool, we'll call it pool, is going to be everything after that 4th card. So that's that. And I'm just going to pull this down a little bit here. Let's center things up. And then we have discarded. And I'm not going to treat this as the cards that score points. I'm going to treat this as the cards where we cannot make a play, so we put one to the side. Let's do our pool there, and our discarded list can come out pretty far as well. I guess we can never have more cards than our discarded from here, so let's just make it go out to there. So that's our discarded cards. So I'm just going to insert a few columns to give me some working space at the side. And basically, let's pull that as well. Didn't want that to happen. There we go. First of all, let's figure out what happens. We're either going to dispose of the middle cards, or all of them, or none of them. So let's say if rights of this equals rights of this. So that means the suit is the same. So we dispose of the mid only. Otherwise, if the left of that equals left of that, then give me all. We get rid of all cards. Otherwise, give me none. So in this situation, we get rid of no cards. And at each level here, I want to build up what the deck looks like given on that rule. So I'll have 3 rules, and I have similar rules for the discarded pile. So let's do our discarded pile first. I want to say if this equals none, then we're going to discard this. Otherwise, we're going to have what's in our discard pile before. However, we also need to consider when we have this that there might be something in our discard pile already. So it's actually going to be H stack that with our discard pile. So that will do for now. We'll adjust this later for the mid and all rules because obviously things will come back out of the discard pile. So now let's do our rules for what's in play next. So let's do all first of all. So if this is all, then we got rid of these 4, and we're going to first pull from the discard pile if we can. So let's say H stack this, but we only want to take a maximum of 4 of them. So let's say take 4. After that, we're going to pick everything. We're going to pick everything from this pool. I'm not going to take any specific amount of columns or whatever from here. I just want it to, because that will automatically just be the pool for next time. And I want to just H stack those together. Now our next consideration is if this equals mid. So if it's mid, I actually want the discard cards first again, and I want 4, and I want to H stack that whole thing with the cards that are still in our hand from the last round, so it's the first and 4th card, and this array here. And the value if false means we're in the none condition. So if we're in the none condition, we've discarded the first card, and our next 4 cards are these, so we're just going to pull that whole array. So because we discarded nothing, let's just center up. I'm going to actually give myself a tiny bit more viewing space. We couldn't use a card, so the 5 got pushed to the side, and then we got a new set of cards. So it's the 4, 7, 4, 2, 4, 7, 4, 2, and then we can pull this down, and we get none condition again. So we can do this, and in our discarded pile, we can pull that down. Now there's one issue that tripped me on a few solves before. So when cards get pulled in from the discarded pile, they actually get pulled in. So let's say this 4 and 5 got pulled in. They should get pulled in order that they were discarded. So this is correct. The 4 was discarded last, so that will come in. But it will attach to the left-hand side of my deck. Then the 5 would attach on the left-hand side again. So I actually need to reverse this little take 4 of those. I need to reverse it because they come back on the deck in kind of reverse order. So I have a lambda for that, so I'm just reversing the order of that take, and I'll need to do it here as well. Reverse the order of those taken cards. And then the final problem is I want to get rid of everything here that's a 0 or a blank, and as well there. So let's do that. So I'm going to say let A be that. Filter A where A is not equal to blank times A is not equal to 0. And then we should have a bit of a neater list. Let's do the same on this side. Let A be that. Filter A where A is not equal to blank times A not equal to 0. And then there's one more filter I want to do on this, and that's if the cards get used in this pile, I want to take them out of here. So let's say we didn't have a none here and these cards got recycled into this pack, then I no longer want them to show in this discarded list. So let's think about this. I actually want this to pull off what was in the discarded pile from before, I think. So let's just change that quickly. So if that 5 then got used in the next pack, I want to eliminate it from here. So I want to filter out again where is error X match A in this whole list here. There, that should be it. So let's pull that down, and then let's just pull these down a fair way to see what happens. So right at the end we've matched the mid cards, so that's right, the 10 and the 6 they match on symbol, so we should get rid of Jack and 10, which means in the next one we should have whatever was in this row, whatever was in this discarded list, 4 of those. So we're in the mid section, so it looks like something's actually wrong with my formula there. We're going to take 4 of those, what was at the start of the list, what was at the end of the list, and then this R24 is not working because it's got a hash on the end. So I think I just want to fix that hash quickly to not be spilled in an array. So it's going to be R6 to AK6, AK6. Let's just change that on this bit as well to remove that hash. And then hopefully we get some more cards spilling. Yes, we do. Let's pull it down a bit more in case any go on longer than that. And if basically I want to find an end, so the end is going to be where this becomes an error, I guess. So I'm going to say if error, give me end, and let's just pull that all the way up. And then hopefully we are done. So the way I'm going to calculate the value of all the cards that we've got is I'm just going to see what's left in the deck at the end. So wherever this says end, then what's left in the deck should be all of these cards. So the 8, because there's none, the 8 gets recycled back into here. So this is always going to be what's left. So I'm basically going to say XLOOKUP end in here, return here. Then I get a bunch of cards, and let's filter out zeros and blanks. So let's say let A be that. Filter A where A is not equal to blank times A is not equal to 0. And then there's 2 things I want in my data table. So one is the value. So let's grab the value. It's going to be what we did before. So the card value was question 2, I think. So I don't want the sum on it. I just want that. So let's just copy that formula into here. And I'm going to look up the left of this. It's an array, so I can make it into an array formula. And then I know these are in the case tab, so let's just put case on those. That works. So then I want the sum of that is our value, and one of the bonus questions asks how many cards are discarded. So I want the count of that, 18. So there's 18 cards left. So the amount discarded would be 20. I think there's 24 cards in this deck. 24. 24 minus 18 equals 24 minus 18. So 6 were discarded. And the points is going to be, let's grab our points for the first amount. Let's just put our left of these. I'm actually going to pull it there because I want it to adjust for question 6 as well. So that's our sum. So let's put a 0 if it's not found and do the sum. So that's our total points at the start. So our remaining points, I know this is a bit messy, is going to be, we had 178 points at the start, and this is what's left. So the points we gained were 59. That actually matches the example, so I might have done this right first time, which will be a shock to me. And then let's see what happens with the data table. I expect something will go wrong. Yeah, and it does straight away. So let's look at 121. Okay, we get an error because nothing was discarded at the start. So if that's the case, I think I want to say if error, give me a blank. And I think that maybe fixes it. Okay, now 122, what's wrong there? Again, I need to just pull that error all the way down, I think. I think that might be all I need to do. We have some answers. Let's see what happens. Oh, one wrong. Two wrong, so let's try and fix those. 129, 129. So I can see we only get rid of one set, which is here, which is king and ace, which should be 13 plus 1 is 14, so my answer should be 14. So the cards I have left should be... so these are coming out in reverse order, so let's just reverse our question quickly, see what I did wrong. So these are all the same, and then I don't seem to have this. 5 of diamonds is the same, 10 is there, 6 is there, king is there, 7 is there, king is there. So this 10 I am missing from my list of cards that are left. So let's just figure out what happened to that 10 of spades. It seems to have dropped off of this list at the end because I just haven't pulled this out far enough. So that is literally my only fault. So let's fix that. Anything that goes to BE should actually, let's just take it to like BI instead. So anything BE should go to BI. BI. That might be my only error, which I kind of almost got it first time if that's right. So that's pretty impressive if so. Yeah, and they're all right. So then the count of cards we discard should be 266, which is the sum of those. So let's do that bonus. 266. And then we need to also do question 6, which is supposedly the easier version of this, but really it's exactly the same question. So 101, does it just work? Doesn't look like it because we have one error there, but let's put those in for now. Looks like it works other than 114, 114. So I think nothing is discarded. We get rid of 2, 4, 8, 12 cards. We have 12 cards in our hand. So the problem is we got rid of all of them. But yeah, let's just fix it manually because I don't want to spend too much time on this. There's a total of 91 in the entire deck. So that should just be 91 points, I assume. Yeah, and then I think that's a full score. There we go, that was a hard case. This one took me a while to figure out like a decent solve. I'm still not sure this approach here is the quickest, nicest way to do it, but I do like concise models, so I'm happy about that. It will do. Anyway, that's it. I feel like there's just so many cases to upload at the minute because we got dumped like 6 in a single day from these knockout rounds. It's going to be the same for Vegas. Obviously, there's going to be a day where it's just loads of cases dumped, so we'll see if we can solve them all and upload them.